Okay, good morning class. So today, okay, you guys had some homework. Okay, the homework was exercise. Sorry? Right. Any problems with 1.4? Any problems with 1.4? So 1.4 was dealing with binomial squares and difference of two squares, the conjugate pair then. No? Then 1.5, any issues there? Yes? What was the problem in 1.5? G. Any other problems with exercise 1.5? Okay. Which page is this on? 10. Thank you. Okay. So the girl got it wrong. You read for me what you have in your first line. Go for it. And I'll try and pick up your mistake, okay? Yes? Sorry? You didn't do the sum. You must attempt the sum. Then we know where you're going wrong. You can't just say, I don't understand. But you did all the other sums. So it doesn't make sense why you couldn't have done the sum. Brackets that's in between. Two brackets and a minus sign. There's two brackets. So there's a square in D and a minus sign. So same problem in F. But you got F right. So it's not only G. It's F as well. Okay, so what we must do is we must get rid of the bracket by multiplying the outlines. Okay? So 2x times 2x is going to give you 4x squared. 2x times negative y is negative 2xy. Positive y times 2x is going to give you positive 2xy. Positive y times negative y is negative y squared. We have a negative here because of that negative. Okay, I'm just going to align the board. Okay. But because of that minus there, we'll have a bracket. And as you can see, it's a conjugate pair. I could have done that in the first bracket as well. Not so. Why? Because they're the same provided one is plus and one is minus. I could have left that out there already. Not so. But because she was confused, I'm doing everything. So we multiply that out. So x times x is going to give you x squared. X times 3y is going to give you positive 3xy. Negative 3y times x is negative 3xy. Negative 3y times positive 3y is negative 9y squared. Okay. So what I'm going to do now is I'm going to add like terms. I can add like terms or I can multiply the bracket out at this point. Okay? So I'm going to add like terms. Negative 2xy plus 2xy cancel. 3xy minus 3xy cancel. So it's going to give you 4x squared minus y squared minus open brackets x squared minus 9y squared. So what do I do now? Multiply the negative out. Now some of you would have gone from this straight into that step. Not so? Right, so we know the rule. Alright? So we get rid of the brackets by multiplying the negative in. So what we have is 4x squared minus y squared minus xy. Negative times negative is going to give you positive 9y squared. Again we're going to look for like terms. 4x squared minus x squared is going to give you 3x squared. Negative y squared plus 9y squared is positive 8y squared. You understand, my girl? Did you go watch the video again? That's the problem. That is why we are making, you know these videos of this online? Who doesn't know of the videos that's online? Sorry? What is it? Muhammad Nabil Body. Okay? They'll say they match with Muhammad Nabil Body. Okay? This lesson that we're having now is also going to be available this afternoon. So if you stuck, people, you just go watch the video again tonight or this afternoon. You don't understand. You must remember that your education is in your own hands, people. It's just not enough to say I don't understand. You must take ownership of your education. Okay. Anything else that's a problem with exercise 1.5? And remember, if you ask me a question, you will start off the question. You must tell me, okay, what did you do? Then I can tell you where you went wrong. Okay? That's the idea. I can't do the whole lesson again for you. Okay? Is there any other problems with exercise 1.5? Let's go with exercise 1.6. Any issues there? Yes, so what's the problem with 1.6? Which page is this on? 11. Exercise 1.6, page 11. So no problems here. Okay. However, if we look at number 2, says determine the general rule for question 1D, B and E. So if you look at 1D, this sum here came to be a cubed minus 1. Not so. This one here came to 8 a cubed plus 27. And E, this came to b cubed minus 64. Not so. The others never came to this. The others came to either 3 terms or 4 terms. Not so. So looking at those sums, what do you notice? What do you notice about this? Sorry? They are cubes. Yes, perfect cubes. That is the difference. What makes this difference? It's minus of cubes. And this is going to be the sum of cubes. That's a perfect cube, perfect cube, perfect cube, and so on. Difference is minus, addition is plus. So those 3 sums answer resulted in, or the answer was, either the sum of cubes or the difference of cubes. Not so? Right. But it says determine a rule for this. So we're going to try and see why did this actually result in this, in the sum or difference of cubes. Let's try and make a link here. You see here, there must be a link that's happening between the first bracket and the second bracket. Something must happen. It must happen to those three questions only. Okay? So what do you notice here? Here we got a minus 1. So let's try and link that with this. Here we got the a. The second bracket we got a squared. Here we got the a 2a. And there we got the 4a squared. So what do you notice about a and a squared? 2a and 4a squared. It's being squared. Not so. So let's write that down. So if this is the first term, let's go plus or minus the second term. Let's see what's going to happen. So we said the first term is being squared, not so? Let's see if that is true. Well, what is b squared? B all squared? B squared. So yes, it is true. You see that, people? Let's look at minus 1. Let's look at minus 1 and add positive 1. Let's look at 3. What we ending off with? Positive 9. Can you see that? So how do I get from the second term to the last term of this bracket? Squaring it. Squaring it. Can you see that? So let's look at negative 4. What's negative 4 squared? Positive 16. So to get the third term of that trinomial is going to be the second term squared, whatever the second term is. Not so? So the middle term we need to come with a rule up to the middle term. Okay? So let's see for the middle term. So here we got a. So how can we link a from the first bracket? Sorry? Sorry? It's just a. So how do you get from the first term, from the first bracket to this middle term? There must be a link that's happening between. First times the second, so a times negative 1 is negative a, but here's positive a. If we go with D and we go the first times the second, what is 2a times 3? 6a, but what do we have in the bracket? So what do you notice? It's also negative. So it's going to be the first term, so it's negative, the first term times the second term. That will always be plus 2. You all agree with that, people? So we'll check now if it works. So we say it's going to be the first term. What's the first term? B times the second term, which is negative 4 times the negative. So what is negative b times negative 4? Positive 4b. Can you see that, people? So that is the rule. So here you can write here. It's for the sum or the difference of cubes. If it is the first term plus or minus, and this the rule applies here, then it will result in the first term cubed. If this is plus, if that is plus, then I'm going to have a plus. You see that, people? If that is minus, then I will have a minus second term. Okay, you can put this as a rule. We're going to apply this rule extensively when it comes to factorization. Okay. Yes, Michael, you late? You new? No problem. Welcome. In the school you have? In school you have? Nice. That was dance. Welcome. Okay, so that's the rule. Okay, you guys got it? So, are you so late? What? The traffic is late, not you. Nice, nice, nice. Okay. We are going to look at that extensively. Okay? When we do factorization. Because our learners always get confused with this one here. And I'm sure you guys are not. So let's look at number 2. Number 2 says determine the general rule. We just did that now. Number 3 says find the product of that. So now let's check if this question 3a conforms to this rule. Let's see if it conforms to this rule. Is the first term being squared? Yes. Is the last term being squared? Yes. For the middle term, what's a times b? AB. Is the sign opposite? Yes. So does the rule conform there? Yes. So what do I do here? Multiply the first and the last. It's going to give you a cubed plus b cubed. You see? So if you go on and multiply the whole story out, you would have taken you 2 extra steps. Not so? Oh, 1 extra step, sorry. I'm exaggerating unnecessarily. An extra step. Okay. Let's see if the rule applies here. Is the first term being squared? Yes. Is the last term being squared? Yes. The negative y squared is going to be negative y times negative y, which is positive y squared. Which is the case there. Not so? What? That is negative, so that is positive. Or we can say the first term times the second term times a negative of that. It's going to give you positive xy. Is that the case there? Yes. Yes. So can I apply the rule? Yes. So that the rule means to say I can multiply the first and the last. So x times x squared is going to give you x cubed. Negative y times y squared is going to give you negative y cubed. Okay, but you guys have multiplied it out at this point. Did you guys get these answers? Yes. You guys understand? And that was the end of the homework. Not so? So why didn't you say, why did I give you so little homework? Right, products resulting in the same or difference, the sum or difference of cubes. We just spoke about this rule now. Okay, and here it's given in words. The product of, let me just put it there. The product resulting in the sum and difference of 2 cubes. The product of a plus b and a squared minus ab plus b squared resulting in the expression a cubed plus b cubed, and the product a minus b times a squared plus ab plus b squared resulting a cubed minus b cubed. So a cubed plus b cubed is equal to, so here they're going in the reverse now. Can you see that, people? So now they're doing as if they are factorizing. You see that? So a cubed plus b cubed can be written as a plus b times a squared minus ab plus b squared. And a cubed minus b cubed can be written as a minus b into a squared plus ab plus b squared. Note that a squared plus ab or minus ab plus b squared cannot be factorized any further using only real number coefficient. There's no way that this, what we call this, people, a trinomial. Now last year we spoke about factorizing of trinomials. It's not so. However, this trinomial there will never be able to factorize. Okay? For those of you going to do advanced maths, advanced program maths, we'll talk about that in the later stage. No? I'm going to introduce that this year as well. Advanced maths. But then you're going to go into non-real numbers, numbers that doesn't exist. But the whole topic, the whole week and a half is spent on that, studying stuff that doesn't exist. But it's nice. Yes. But importantly for us now at this point is to note that this trinomial here does not exist. It cannot factorize. Cannot factorize. Okay? Do you guys understand? No? Right. So let's do a few of these sums out of exercise 1.7. We're going to do a few sums. Exercise 1.7 we're going to do number 1 and number 1A. This one page 12. Okay, I'm just going to select a few sums we're going to do before we go into the next section of work, okay? So you're going to do E as well. So you guys can start. Okay, they have selected 5 sums. We're going to do this 5 sums out of exercise 1.7 on page 12. I'll give you a few minutes to do those 3 quickly. Guys, finish? You're struggling. No, there's another sum after I. For those of you who are working ahead, it is K and L. Okay. So does the rule apply here? Is the first term squared? Yes. Is the last term squared? Yes. Is that the opposite sign there? Yeah. X times 1? X. So the rule can apply here. No problem. So what do? Multiply the first and the last. So x times x squared, x cubed. Negative 1 times x, negative x. But now if you are a learner that can't remember the rule, you're having problems with it, then you multiply the whole story out. That's all. Then you add your like terms in there. You all okay with that? Any confusion? Who got a different answer to this here? You all got the same answer. Right. Let's look at the next one. E. Is the first term being squared? What is 3a whole squared? 9a squared. Is that the case here? No. So can I apply the rule here? No. So what must we do? Multiply the story out. There's going to be 3a times 3a, 2a squared. 3a times 3ab. 3a times 4b squared. And so on and so on and so on. You guys understand? The 3a times 2a squared, 6a cubed. 3a times negative 3ab, negative 9a squared b. 3a times 4b squared, positive 12 ab squared. Negative 2b times 2a squared, negative 4a squared b. Negative 2b times negative 3ab will be positive 6ab squared. Negative 2b times positive 4b squared is negative 8b cubed. Any confusion there? You all got that? So what do I do now? Like terms. So 9a squared b and negative 4a squared b. 12ab squared and positive 6ab squared. So we're going to give you 6a cubed. What is negative 9a squared b minus 4a squared b? Negative 13a squared b. What is 12ab squared plus 6ab squared? Positive 18ab squared. Minus 8b cubed. Okay, you will understand. Next, let's check if the rule applies here. Is the first term squared? Yes. Is the last term squared? Yes. If that had to be minus, could I have applied the rule still? No. It has to be positive. No? So is that last term? Yes. Is that's a plus? So is that a minus? Is it opposite? Yes. 5a times 2 is 10. So can I apply the rule? Yes. So we multiply the first and the last. What is 25a squared times 5a? 125 a cubed. What is 2 plus 4? What 2 times 4? And there we go. Any confusion here? You all got it. Let's look at K. Not done? Okay. Yes? Sorry? Yeah, this tissue. Why are you taking all of that? Yeah, but you're also taking a lot. Huh? For water. Okay, now you can use it to now leave my tissues. Yeah. Okay, it's a pleasure. Now why are you throwing the water out in my clothes? Uh-huh. Okay, guys, ready? Okay, is the first term being squared? Yes. Is the last term being squared? Is the sign opposite? What is 3x times y? 3xy. Is that the case? Can I apply the rule? No. All those conditions has to be met before we apply the rule. If you're not sure, you multiply the square. Okay. In this case, we can't apply the rule, so we go multiply. So 3x times 9 or x squared is 27x cubed. 3x times 6xy is going to give you 18x squared y. 3x times y squared is positive 3x y squared. Negative y times 3, negative y times 9x squared is negative 9x squared y. Negative y times 6xy is going to give you negative 6xy squared. Negative y times y cubed is negative y squared is negative y cubed. You all agree with that? Now we're looking for like terms. 27x cubed. 18x squared y minus 9x squared y is going to give you positive 9x squared y. You all agree with that? 3xy squared minus 6xy squared is going to give you negative 3xy squared minus. Any problems there? No? And the last sum of this exercise that we selected, is the first term being squared? No. So it automatically was going to apply the rule. 5a times a squared is 5a cubed. 5a times negative 2a is negative 10a squared. 5a times 2 is going to give you positive 10a. Negative 1 times a squared is negative a squared. Negative 1 times negative 2a is positive 2a. Negative 1 times positive 2 is negative 2. What do I do now? Like this. So 5a cubed minus 11a squared plus 12a minus 2. Any issues there, people? No? You all agree with that? Okay, I just added like terms here. Those two are like terms. What make them like terms? The variables are the. Okay. So for homework, I want you guys to do the remainder of exercise 1.7. And this is on page 12. 1.7 on page 12. So now your next heading is collecting like terms. Example 1, and it's on page, which page is on? 12, 13. Collecting like terms. So we are told you can simplify an expression by collecting like terms. Okay. So example 1 on page 13. Write that down as your reference, and you write the sum down as well. Okay. So firstly, the question says expand and simplify. How many terms are there in that expression? 3 terms. You all agree with that? What separates terms is? Plus and minus signs. Okay. So looking at the first term, what can be done in the first term? Multiply the 3a. Not so. In the second term, multiply negative 2a squared. Not so. The next one, in the last one, the third term, multiply the negative sign. Not so. Alright. So multiplying, let's see what we get. So what is 3a times a? 3a squared. What is 3a times a times 1? Positive 3a. You all got that? What is negative 2a squared times a? Negative 2a cubed. What's negative 2a squared times negative 7? Positive 14a squared. What is negative? If there's nothing, there's a 1 there. Not so? Well, what's negative 1 times a cubed? Negative a cubed. What is negative times 7a squared? Negative 7a squared. What's negative times negative 4a? Positive 4a. What's negative 1 times positive 1? So what are we going to do now? Collect the items. Insert heading, collecting items. Right, so collected items, added items. Alright. The first thing is to multiply with a bracket. Secondly, we're collecting items. So 3a squared is an item to what? 14a squared and negative 7a squared. What's up? A. 3a is an item to 4a. Negative 2a cubed is an item to negative a cubed. And that negative 1 is on its own. Not so? So what is 3a squared plus 14a squared? 10. 13a squared. Now I'm getting them still. Yeah, don't even give me a chance. 3a squared plus 14a squared, 7a squared. 7a squared minus 7a squared. 17a squared minus 7a squared. There we go. So 3a plus 4a, positive 7a. What is negative 2a cubed minus a cubed? Negative 3a cubed minus 1. You could have started off with adding the highest exponent. Then your answer would have been negative 3a cubed plus 10a squared plus 7a minus 1. That, if you had started off writing it in DCD powers. But are you going to lose anything if you write it in this order? No. Okay, that is just the conventional way, the normal way. Okay. But we're not normal, not so? Alright, you all okay with that? Alright, so let's look at example 2. Example 2 on page 13. Okay. So how many terms are there in the sum? 3 terms. Expand. What does expand to multiply? Okay. There are 3 terms there, people. So let's look at the first term. What needs to be done in the first term? Can I multiply the 2 in first with everything there? No? If you want to multiply the 2 in, the 2 will only go into the one of the 2 brackets. Either in the first bracket or the second bracket. But to keep the sum small, okay, initially, what we're going to do is, we're going to keep the 2 on the outside and multiply that in. That's all. We're going to do that. So let's go and multiply in. What do we get? X times x is? X squared. X times 2 is? 2x. You all agree with that? What's negative 3 times x? Negative 3x. So it's 2x minus 3x. What's 2x minus 3x? Negative x. You see that? Let's make it a bit easier. Or shorter. What's negative 3 times 2? Negative 6. Now some of you would have x squared plus 2x minus 3x minus 6. That's also correct. Nothing wrong with that. But you'll see me doing the step here in one. That these 2 steps, you'll see me incorporating it into one. Okay? So that the sums are going to become bigger. So we'll try and make the steps a bit shorter. Okay? You all okay with that? But again, people, if you feel that it's difficult for you to do that, no problem. You write it out, you multiply the story. No problem. You're still going to get a full mark. People, here we're going to apply the square first in the second term. We're going to apply the square first. And at this point, we spoke about the binomial square rule. Not so. Who can remember what the rule was? First term squared, which gives us x squared. For the middle term, first term times 2. Which is going to give us what? Negative 4x. Nice. And it's going to be the last term squared, which is going to be positive 4. That will always be positive. Again, people, if you are getting it wrong, don't keep yourself brave. What must you do? Write it out twice. Multiply that. Okay. It's not worth it. Keep yourself brave, people. They lose a lot of marks. Let's look at the third term. What do you notice here? The conjugate pair. Okay? So it will result in the difference of 2 squares. Can you see that? How do we know that? It's a binomial by a binomial. They are the same, provided one is plus, one is minus. That's what we call conjugate. The conjugate pair. They are the same, provided one is plus, one is minus. Okay. So if that is the case, what can we do? The first and the last. Not so. So it's going to be open brackets. X squared minus 24. Can I add the like terms at this point? No. So what do I do now? Multiply out. Get rid of the brackets. Get rid of brackets there. Multiply the negative 2 in, the 2 in, sorry. Negative 3 and the 5. Let's do this together, balancing shortly. Soon. 2 times x squared, 2x squared. Okay? 2 times negative x, negative 2x. 2 times negative 6, negative 12. Negative 3 times x squared, negative 3x squared. Negative 3 times negative 4x was positive 12x. Negative 3 times 4, negative 12. 5 times x squared, 5x squared. 5 times negative 25, negative 1. Any confusion here? Am I on track here? Am I on track? Did I make a mistake? Okay. I feel better about myself, no? So what do we do now? Like terms, yes. Like to be unlike. No? Yes, like to be unlike. Okay. Do I have to do what I'm doing here? No. But it just helps the course, okay? So 2x squared minus 3x squared is negative x squared plus 5x squared, 4x squared. Negative 2x plus 12x is positive 10x. Negative 12 minus 12 is negative 24 minus 125 is negative 140. Do you all agree with that? Any issues there? No. For homework, I want you guys to do exercise 1.8. Now, in 1.8, you do for me in number 1 ACE and number 2 ACE, and that's on page 13. Okay. People enjoy the rest of your day. Good morning, class. That girl that doesn't know about the YouTube channel, bring your phone, I'll connect you to the channel.